Hello students, welcome to Sreenath. In this video, we are going to discuss the 14th chapter from 7th class CBSE Science, which is nothing but electric current and its effects, students. So, electric current and its effect. So, before we are going to start this session, we will see the overview of this whole chapter, students. So, we are very much related and linked to the electric current, students. It is one of our basic needs. It is our part of life. If there is no electric current, so there are so many functions in our society, so many companies, so many functions will stop working. So we are highly dependent on electric current, and we are highly dependent on internet, and we are highly dependent on data, like that, students. So it is becomes one of our basic essential, students. Okay, so like food, water, like that, shelter. So electric current is also one of our basic essential. So in our day-to-day lives, and in our houses, and in our schools and colleges, and whatever it may be, at every place we use a lot of electric current. There is a lot of usage. So many appliances, so many things will work only whenever there is electric current. If there is no power, no electricity, so all this won't work, students. So what is my main aim is what is my basic theme is that, students, we are highly dependent on electric current. So now we are going to learn about that electric current and effects of that electric current, students. So cheer up, guys. So now we will start the overview. So first thing is symbols of electric components. So we know in an electric circuit there are some electric components, and they are having some symbols. Here we are going to know what are the symbols for those electric components. So that is the thing, students. Okay, and next, after completing the topic, students, we are going to discuss about heating effect of electric current. So because of that electric current, we will get some heat. So basing on that heating effect of electric current, there are so many appliances working: electric kettle, electric heater, so many like that. And next thing is, after completing all these things, magnetic effect of electric current. So besides the heating effect, there is also magnetic effect of electric current, students. We are going to study about the magnetic effect also. Okay, students, so these are the things. And next thing is electromagnet. So what is an electromagnet? So about it also we are going to learn, and electric bell. So about all these 5 topics we are going to learn, students. Okay, so this is our present chapter. So this is our present chapter overview. So we start our discussion, students. So first thing is that symbols of electric components, students. We know in an electric circuit there are so many electrical components. So while writing the circuit diagram, while drawing the circuit diagram, if you use the electrical components symbols, it is very easy to draw. So that's why we use symbols. So for addition, subtraction, there are symbols. Like that, we are having symbols for the electric component, students. Okay, so if you see, it is the electric cell. So for it, the symbol is like that. So the longer one is positive symbol. It is the positive, and it is the negative terminal. And this is the electric bulb, and which is switch on, like this. The symbol is like that, students. And whenever the switch is on, it is like that. And whenever the switch is off, it is like that. And a battery, so there is a difference between a battery and a cell, students. If so many cells, one or more cells are connected, then we call it as the battery. And battery symbol is like that. And wire, connecting wires, we use the conductors, copper wires. These are represented by straight lines, like that, students. So these are the symbols of electrical components, students. Okay, that is the case, students. So that is the thing. And what is meant by battery, students? We know for single cell there is a positive terminal and negative terminal. And what about the battery? For battery, so battery means there are so many cells which are connected, more than one cells. we call that as the battery, students. Such a combination of two or more cells is called as a battery, students. That is the thing. So many devices such as torches, transistors, toys, TV remote controls, all these use batteries. So if you place single cell, they won't work. They need more number of cells, which means we call that as a battery. So they need battery, students. Okay. So how they are connected? So we are using more than one cells, but how they are connected? There is series connection and parallel connection, students. So most probably we use series connection only, students. So in the series connection, how we will connect one or more battery, students? So it is the single cell, students. Positive, negative. If you want to connect more cells, how you connect with the, students? The negative terminal of first battery is connected to the positive terminal of the second battery, and this is continuous, and the negative terminal of second battery is connected to the positive terminal of third battery, like that, students. So we call this as the battery. Like that we connect cells, students. It is called as series connection. Okay, students, like that we will connect. Okay, so if you want to prepare one battery stand, if you see here, students, positive, negative, the negative is connected to positive and negative, here 4 cells, but every time if you match up them in a single line like this, it is somewhat difficult for making appliances or anything, students. So for that we will connect them like this. So the positive, so this is the positive, and the negative of this is connected to positive, and the negative is connected to positive. Like that we will connect, students. Okay, so that we can save. So if you see, students, our cell holders in our in our torches or remote controllers or whatever it may be, in all those things, these are like this. Okay, students, so they are side by side. Then you may got some doubts, sir, they are side by side, and how they are connected in series, sir, means. So if you carefully observe, students, we will place them one opposite to other. Suppose if you place them like this, if you place the positive terminal of one battery here and negative terminal of one battery here, so obviously here we will place the negative battery and negative terminal, positive battery, positive terminal, like that. So what happens if you connect both these things? What happened? And if you connect both these things, obviously the negative terminal of first battery is connected to positive terminal of second battery, and this will goes. So what happens? So this goes to the bulb, and this goes to the bulb. So positive, negative. So it is the series connection. Like that they are connecting, students. Okay, and if you want to make your own cell holder, for that you need a wooden table, a wooden board like this, students, and we need some irons like this, and we'll nails we will match like this, and we will place cells like this, and there is a rubber band to to make tight the cells. Like that we will connect. This is the negative terminal, this is the positive terminal. So this is the thing, students. Or you can buy the holders like this also, students. So it is the battery, students, in the trucks or in the vehicles, students. So that is the thing about batteries and cells. That's it, students. So make the electric circuit. Let us now draw a circuit diagram of. So now we are going to learn how to draw a circuit diagram, students. So for this we are drawing the circuit diagram. So we know we will use the circuit symbols of the electrical components. So this is the battery, and what is its symbol? So it is the plus and it is the minus. It is the wire. It connected to bulb. So it is the bulb. And next it connected to switch. So it connected to switch, and the switch is closed. That's why it is like this. It will goes and it connects to bulb. So it is like that. So it is the circuit symbol, students. So first thing we will do is just we will replace the symbols. Bulb, for bulb this is the symbol, for wire it is straight lines, and for battery or cell it is like that, and for switch it is like that. That's it. So simple, students. It is another circuit diagram. And one more thing students, in the bulb there is a thin wire. If you see in the bulb there is a thin wire, we called it as the filament students. So filament. So whenever the current passes through the bulb, the current enters into the filament students. So whenever the current enters into the filament becomes heat. It will be heated. So it will be heated to high temperature and it will starts glowing. In this way the bulb will glows. This is the scenario happening students. Okay, so if high current is passed students, the filament in the bulb will get fused. After that the bulb won't work students. Like that is the thing. Whenever the filament of the bulb is broken, it is not a complete circuit students. So whenever the filament of the bulb is not open, it is a complete circuit, but whenever it is not, it is broke, it is not complete. So next topic is that heating effect of electric current. Heating effect. So take an electric cell, a bulb, a switch and a connecting wires. Make an electric circuit. So first thing is that friends, you have to made an electric circuit, simple electric circuit, like in the previous, and whenever the current switch is on, circuit is complete, current will flows. As long as the current flows, the bulb will close. So wait for some time and switch on, switch off, so that what happens, the bulb stops glowing. And now touch the bulb, what you feel, that bulb is hot, it is heated. So what is happening, whenever the current is passing through the bulb, it is become heating. So the current will gives heat or will makes heat. Okay students, on this concept our electric heaters, okay students, our electric heaters like this all are working students. Okay, so that is the case. So if you see here students, it is the one of the electric heater like that. So if you see in some cases students, if current flows, because of it the coils will becomes very hot, red hot students. So this is the heating effect of the electric current students. In all electrical appliances, what happens is that students, there is a coil. Okay students, so that coil is made of some metals. So thus coils will becomes red hot, sometimes becomes very hot, so that it will transfer the heat energy students. That is the thing, is the bulb filament will heat it up. So this is the case students. So finally, how much heat will be delivered, it is depending upon the material. How much heat is produced when a current is passed, depending upon the material and its length and its thickness students. That is the thing. Basically the wires used for electric currents will do not become hot students, but at the same time some appliances will becomes very hot. Same current is passing, but for that same current some are becoming very hot, electrical appliances, but the current connecting wires are not becoming that much of hot students. And tube lights and CFLs or the compact fluorescent lamp students use this and search for ISA mark. It is the standard branded, so that they will save your current, they will reduce your current bill students. Okay, so here fuse used in buildings. So here the concept comes fuse students. If you see here, it is like that. So basically because of the current, if there is any heating in the electrical appliances, or if there is any large heat, or if the large current flows into the building, to avoid it we will place the fuse students in our house. So the current travels from the fuse, later it goes into your house on all appliances students. So if there is any heating or any high current in the appliances, then the fuse will break, students. Why means here we will place very thin copper thread, so thin copper wire, so that because of the heating effect, if there is large current or large heating effect inside the building, so the current first have to travel through this fuse. So if the current is heating that much, then this will breaks, and the current circuit, there will be no current in the building, students. So nowadays these types of fuse will be visible in the electrical appliances. So if it breaks, then there will be no current, so they will heat up, break up if high current comes. So nowadays miniature circuit breakers are used, students. So these are MCB, students. These are advanced technology. So next thing is magnetic effect. Magnetic effect of current, students. So now take a matchbox and place a compass in it and curl a wire on it, and connect that wire to bulb, and connect that wire to power supply like battery, and connect that wire to switch. So now switch on. What happens when the switch is on, the circuit is closed and the bulb glows. At that time the magnetic compass will show some deflection. So we know whenever the magnetic compass will shows deflection, students, whenever there is so magnetic compass is made up of magnet, tiny magnet. So when you leave it on a space, it will shows the north and south direction. We know about that. So here it is showing some deflection. So whenever it shows, so basically if you talk about the magnetic compass, if you talk about it, so it will shows a deflection. If you take this magnetic compass to near to a magnet, it will shows deflection. Until it will not shows deflection, it will shows the north and south direction. So at the same time here also it is showing deflection, but there is no magnet surrounding here. So which means the current flowing in this wire is acting as a, or behaves as a magnet. That's why it is showing different. So this is called as the magnetic effect of current. This was discovered by Oersted, students. Hans Christian Oersted, he was observed these things, students. So now take a nail and take a wire which is insulated and make curling like this and connect it to a power supply, which means a battery, and take some, now switch on and take some iron fillings near it. What happens, they will come and attach to this. So which means this wire is acting as a magnet. Magnet only attracts the iron fillings, no? That is the case. Now we are going to discuss about electromagnet. What is electromagnet? So to know this, students, this is the activity we have already done. So 75 centimeters long piece of insulated wire we have taken, and we have 6 to 10 centimeters iron nail we have taken, and we have curled the wire on here, and we have power on, and we have placed some iron links. What happens whenever the current is, whenever you switch on, the iron fillings will come and attack this. Whenever you switch off it, they will not be attracted. So whenever current is passing, then only it acting as a magnet, and whenever there is no current, it is not acting as a magnet. Okay, students. So this is called as electromagnetism, and these such coils are called as electromagnets. Whenever there is a current, electricity, then only magnet. That's why electromagnet. Whenever there is no current, there is no magnet. That is the case, students. So in the cranes there are strong electromagnet students, so because of it they will lift heavy loads students, and we using these electromagnets we will separate the junk and magnets students. Next thing is electric bell. How it works? So this is the circuit of the electric bell students. So what happens is the students, here there is a wire which is coil of wire students. So whenever the current passes through it, they will act as a magnet. So there is an iron strip here students, and there is a screw near to it students. So whenever the screw touches the iron, this iron strip to one of this iron strip is connected to a hammer students. Whenever the screw touches this iron, so what happens, the circuit will be closed, and current will be flowing on these things, and they will act as magnets, and they will attract this iron thing, so that it will comes near it, so that it will hangs this thing, and whenever it comes near to it, so it will leaves the screw, so that the circuit is breaked. So at that time these coils will not attract the iron strip, so they will left them, so it will goes back to same old position. So whenever it is going back to old position, again circuit completes, and again it is attracted, not repelled, attracted, repelled, like that. This will moves like this. So this hammer which is connected to iron strips will comes and knocks like that. So this happens students. So this is the working of the electric bell students. Okay, so finally our chapter is completed students. Hope you have understood well students. So if you have any doubts, please feel to free to comment below. Have a nice day students. So keep smiling. Before we are going to stop this session, let's see the summary. Electric current and its effects students. First thing is the symbols of electric components. So these are the electric components, and these are the symbols. And battery is nothing but one or more cells connected, called as battery. So in this type they can be connected. Next thing is circuit diagram. We are using the symbols, we can draw the circuit diagram. Next thing is heating effect of electric current. So because of the flow of electric current students, there will be heat produced students. So this heating effect is because of the electric current students. Basing on that concept, electrical appliances will work students. Okay, so if you see some materials like nichrome, those will becomes very red hot for the same current students. Okay, some materials are like that. So and how much of heat is produced depend upon the material and its length and its thickness students. Next thing is about MCB students. So it is the fuses which are helpful, and this type of fuses and advanced fuses are MCB students, like that. Next, magnetic effect of electric current. So whenever the current flows, it acts as a magnet, electromagnet. So this is the electromagnet. Whenever the current flows, then only it acts as magnet. Whenever the current stops, then it not acts as magnet. Those called as electromagnet students. Okay, next thing is electric bell. We have discussed how the electric bell works clearly. So our chapter is completed, our summary is also completed. So have a nice day, keep smiling. Bye bye students.